Lesson 8-6, solve problems involving area of a circle. In this lesson, we're going to expand on the use of pi and circumference in order to find the area of a circle. Let's first take a look at the Explore It problem. LaToya cut a circle into 8 equal sections and arranged the pieces to form a shape resembling a parallelogram. Notice in the picture, the circumference, which is C, is equal to pi times d, but they've rewritten that in terms of radius. 2 times pi times r. So if I know that 2 times the radius equals the diameter, then I can rewrite the formula C equals pi times d as C equals 2 times pi times the radius, because 2 times the radius makes that diameter. You should also notice in the picture, in the circle specifically, that the center of the circle here that I've marked in blue is what we use to cut those into sections. And any point on the outside of the circle into the middle of that circle is going to be a radius. And that also includes these measures here that go through the middle of those sections back toward the center. Now, why is that important? Well, because that's what's going to help us solve the problem. So now let's take a look at part A. How is the base length of the new shape, and by new shape they mean this one, related to the circumference of the circle? Circumference, remember, is equal to 2 times pi times r. The base of this shape, this new shape here, is equal to half of the distance around that circle. So I'm outlining that right now in red. If I take those green sections and I were to cut them all out and lay them so that those edges, those corner pieces match up, as you can see here in the picture, then I would be halfway around the circle with that base length. So the base length of my new shape is half times the circumference. Part B, how is the height of the new shape related to the radius of the circle? Well, remember when we were drawing in those radial measures here, okay, the radius not only goes from the corner of the triangular section to the center, but it also goes from that central point back to the edge again. So each of these right here that I'm drawing in that tells us how tall those triangular sections are is considered to be a radius. Now we can use those two facts in order to find the formula for the area of the new shape, which will tell us more about the area of the circle. Since the new shape was made from a circle, let's use that information to get the formula area equals base times height, but this time in terms of a circle. So for the parallelogram that you see in that picture, okay, remember that's the shape right here that I've outlined in red, and it looks like that with all those circle sections. The area of a parallelogram is the base times the height. And that height is the top to bottom measure. So we're going to do the same thing, but this time the height is equal to the radius. Okay, the height of that shape is the same as the radius of my circle. And the base is equal to half of the circumference. So I'm going to put those two parts together and multiply them. But instead of using C for circumference, like I did here, I'm going to use 2 times pi times r. So base times height means 1/2 times the circumference, which again we're going to use 2 times pi times r. This is my height, or this is my base right here, times the height, which is the radius. Now you're saying, okay, what does that do for me for my formula for area? So hold on just a second, and that's what we're going to simplify. So now all I've done is rewritten what I had down there in part C over here on the right side of my page so that I can simplify. 1/2 times 2 is equal to 1 whole. Remember, those are reciprocal, so they make 1 whole. We still have pi, and we have r times r. And if you'll remember, r times r can be written as r squared. So the area of a circle can be found by multiplying pi times the radius squared. Example 1. Solve problems involving the area of a circle. The floor of a new butterfly conservatory will be a circle with an 18-foot radius. The material for the floor will cost $3.95 per square foot. About how much will the floor cost? Step 1. Use the formula for the area of a circle to find the area of the floor. In this problem, we're going to use the approximation that pi is equal to 3 14/100. So we substitute that into the formula for pi. Next, we have to know the radius of the shape, in this case, the butterfly conservatory, in order to know what to put in place of r. In the sketch over here on the right, you see that the radius of that conservatory is 18 feet. So that goes in place in the equation there. Next, you have to do the 18 squared. So remember, 18 squared means not 18 times 2, it means 18 times 18, which is 324. So this is where that 324 comes from. And now we need to take that 324 and multiply by pi to get the area 1,017 3600 square feet. So the area of the floor of that conservatory is about, this is an estimated number, 1,018 square feet. Step 2 is to calculate the cost of the necessary floor material. Now, they rounded the amount of flooring here that they used in that problem. Why do you think they rounded it? Is it possible that I can buy 36/100 of a square foot of flooring? Well, of course it is. But at the same time, I don't want to have the case where I don't have enough flooring. Or maybe I cut it wrong and I need extra. So it's always better to round up to the next whole number. Then you need to multiply the amount of the amount of flooring, which is in square feet, times the cost per square foot. And once you multiply those, you're going to get the total cost of that flooring, which is about $4,021. In fact, they estimated here $4,021.10. Now let's go down to the try it. At a school play, there is a spotlight above the center of the floor that covers a lighted area with a radius of 7 feet. So immediately I see a number here that I need to use to find the area of that lighted area on the floor. What is the area covered by the spotlight? So A equals pi r squared. And notice that this time they want us to use the fraction 22/7 in place of pi. So what is the radius that we need to substitute into our equation? The radius of 7 feet goes here in the box. And that number is going to be squared. So remember, 7 squared means 7 times 7, which is 49. Now I need to multiply. Don't forget, when you multiply a fraction times a whole number, you're going to multiply the 22 times the 49 and then divide by 7. So do that and then come back and check your answer. And the answer is 154, which means the spotlight covers an area on the floor of about 154 square feet. Now take a look at the convince me. In this problem, or in this question I should say, it asks me about what to do if they give me the diameter of the circle. How would I find the area? Well, the area formula doesn't use a diameter. Instead, the area formula needs the radius. So if that's the case, we need to take the diameter and divide by 2, because remember the diameter goes all the way across the circle, to get the radius. And then once I know the radius, then I can substitute into my formula. Just like with all of our other problem-solving work, we can also use information about the area of a figure or the area of a shape in order to work backwards and find the radius and the diameter. So now look at example 2. The athletic department wants to paint the school's mascot logo on the gym locker room wall. They start by painting a solid blue circle on the wall. What is the maximum diameter of the logo if only 1 quart of blue paint is used? Well, in order to do that, we need to first of all look at our formula for area. Pi times r squared. The radius is the unknown measure in the equation. What we already know is information about the area that the paint will cover. Look over here at the picture. It says 1 quart of blue paint will cover 78 5/10 square feet. So this is the area of the shape if I am only allowed 1 quart of blue paint. So now I substitute this information into my formula. I also will substitute in for pi, 3 1400ths. And the r squared is the part that I don't know. So that's what I'm going to solve for. Now treat this like you would a one-step equation. If you're looking for r squared and it's being multiplied by pi, then you need to divide both sides by 3.14 in order to get the value that is the variable. In this case, 78 5/10 divided by 3 1400ths is 25. So that means r squared is 25. We still need to know, though, what is the value of the radius. So what number times itself is equal to 25? So what number times itself makes 25? And that answer, of course, is 5 times 5. So the radius can be 5 feet for that logo. If the radius is 5 feet, the diameter can be up to 10 feet. Remember, radius and diameter are related by 2. Next, let's look at example 3. This example is quite a bit more complicated, but still uses everything that we know about circumference to find area of a circle. Ellie needs new grass and the circular pen for her chickens. What is the area of the pen? Well, the first thing that I notice in the picture is that they have identified how much fencing was required to make that circular pen, and that is 176 feet. In other words, the circumference or the distance around the outside of that pen is 176 feet. My pen will right there. There we go. So that's the circumference. In order to solve the problem for area, I have to know the radius of the circle. But working backwards is how I have to get that radius, because the picture does not tell me how much the radius is from the center of that circle to any of those edges along the fence line. But I can find that information by working backwards from the circumference formula. Remember, circumference is equal to pi times d. But again, d, diameter, is equal to 2 times the radius. So circumference is also equal to 2 times pi times r. In this problem, they have us use the approximation 22/7 in place of pi. So I'm going to substitute in what I know into the circumference formula and solve for r, which is the radius. So 176 goes in place of circumference. The 2 stays right where it is. And pi is the 22/7. R is the piece that I need to find. So the first thing that I'm going to do in my problem is I'm going to simplify by combining some like terms there, okay, by multiplying 2 times 22/7. And 2 times 22/7 is 44/7. In order to solve the next step of the problem, I need to use that reciprocal relationship. So multiply both sides of your equation by 7 over 44 to get a value for r of 28. Now, how did that happen? Remember that 7/44 times 176 means do the multiplication here first, 7 times 176, and then divide that by 44. That's where you get the 28 from. Since I know the radius of the pen is about 28 feet, then I can use that information to find the area. So next I'm going to substitute in for the area formula. Pi again is the 22/7, and the radius of that circle is 28. So I'm going to do 28 squared, which means 28 times 28. Now they skip showing you these steps in the work, but 28 times 28 is 784. So your formula here ends up being 22/7 times 784. So again, you're going to multiply the 22 times the 784, and you get 17,248. And then you're going to divide that by the 7, and that's where you get the 2,464 square feet for the area of that pen. We're going to go ahead and skip the try it questions at the bottom of the page, and we'll come back to them if we have time later. For now, I'd like for you to go on and look at your do you know how and do you understand questions along with the practice and problem solving. Those problems will give us the practice that we need in order to successfully solve problems on our own.